answer to number 1 is choice 2. So with anything that I'm going to go over as far as the multiple choice is concerned, if you got the correct answer and you really know how to do it, then just fast forward through the video to the next question. Okay, if you guessed, then watch the video. All right, so for number 1, it says average rate of change, and that phrase right there means slope. And here's your slope formula. So basically what you need to do is you need to do the slope 4 times and see which one is the greatest. So I'm just going to show you the first 2. So the answer is choice 2. I'm not going to go through these 2 because I think once I show you these first 2, you'll kind of pick up the trend here. So if I want to find y2 minus y1 for this first grouping from 1850 to 1910, these years are all your x values, and these populations are all your y values. So simply you just go to, I pick the largest year, which is 1910. Here's its y value, so that goes right here. Then I do 1850's y value, which is 629. So 29,860 minus 629. And then the x values are the year that corresponds with that y value. So 1910 minus 1850. And then just put this in your calculator and you'll get a numerical value. Same thing with this one. So I went to 2010, there's its y value. I went to 1990, there's its y value. So I took these 2 y values and I subtracted them, and I took these 2 x values and subtracted them. That's what I did here. And again, I just put it in my calculator, and you would repeat the same thing with this one, okay? And then when you have all 4 numbers, like I think this one ends up being 487. This one's 14,805. This is like 5,000 and change, and this is 2,000 and change. So this is the highest number, okay? Because they want to know when the average rate of change is the greatest. All right, number 2, the answer is choice 3. You know what I'm going to say. It wants to know which one's not equivalent. So you're going to take this, remember, to store x, enter. Get an answer, and then all you're going to do is type this one in, so on and so on. Now, this one's just a tad bit different because it wants to know which expression is not equivalent. So meaning if you do to store x and you get an answer for this, right? When you put this in, you should get the same answer as when you put this in. Same thing here and the same thing here. This is the one where you'll get a different answer, and that's what that means. Not equivalent, wants a different answer. Okay, all right. For number 3, the answer is choice 4. Now, you can do this 2 ways. You can factor, or you can cheat. So for example, for the answer is choice 4, you could do -5 store as x, and then type in this expression and see if you get 0, which you do. Then you would do -3 store as x, type in this expression, see if you get 0, which you do. And the same thing, 2 store as x, 3 store as x, and all of these should give you 0. Okay, whereas if you look at, let's say you look at choice 1 here, this matches all the numbers that are, oh no, I'm sorry, actually, I lied. It does not. That's a -2, and this is a +2. All right, so I'm going to go back on what I said. Now, if you wanted to do this algebraically, and I know how much you loved factor, you really should know how to do this. So what I'm going to do is group in groups of 3. And I see that the first 2 terms, the x to the 4th and the -9x squared, they have a common factor of x squared. So that would leave me with x squared minus 9. The second set of terms, they have a 3, and they also have an x. So that leaves me with x squared minus 9. And then this last grouping, if there is ever a negative as your first term, I like to take a negative out. Okay, so I see that 10 goes into it, but I'm going to make this -10, and that will leave me with x squared minus 9. Now I know that I did this right because these all match up. Okay, all right, so then I'm going to take all my GCFs, which is the x squared, the 3x, and the -10, and then the repetition binomial, so to speak. Okay, now I'm not done factoring yet though. So I want to figure out for that first grouping what adds to 3 and multiplies to 10. So I know 5 times 2 is 10. I would open up 2 sets of parentheses. X, you can just put 5 in one and 2 in the other. And I want to get a positive 3 when I add, so I'm going to do a positive 5 and a negative 2. Do make sure that you check this. So this adds to a positive 3. Does it multiply to a negative 10? And yeah, it does. And then lastly, this is the difference of 2 perfect squares. So I'm going to go like that. And zeros are just taking each of these guys, and technically we're setting, I'm not going to do this every single time, but we're setting this equal to 0. Okay, or the trick is just change the sign, change the sign, change the sign, change the sign. Okay, so there's your algebraic way. Number 4, the answer is choice 2. Okay, so I'm going to do this one the way we did the other day. So they gave you this point. So I'm going to go negative 2 and then down 3, which means that point is going to be right here. And remember, when we have a terminal side that comes out from the origin to that point, and then we always draw a triangle, but remember it goes to the x-axis. So in this case, I'm going up like that. So this distance is 2, and this distance is 3. Okay, because I went to the left 2, and then I went down 3. Okay, so they want the numerical value of tangent. So remember SOHCAHTOA. And tangent is the opposite over the adjacent. Now this theta that's right here is always going to be this angle at the origin. Always, 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 always. So if I'm looking for the opposite, I go from that angle and I just draw a line straight across. There's my opposite. And adjacent is next to, which would be this guy right there. Okay, it's not going to be this one. Oops, this one, because that's the hypotenuse. I didn't draw the right angle, but that's a right angle, so that makes this guy the hypotenuse. Okay, so then lastly, tangent of theta would be the opposite, which is 3, over the adjacent, which is 2. The last thing you have to be careful of, and I know we spoke about this, is all students take calculus. Your triangle is in the 3rd quadrant, and tangent is positive in the 3rd quadrant. And that is what they're asking you for. So your answer is a positive 3/2. Hypothetically, if this triangle was up here in the 2nd quadrant and they were asking for tangent, our answer would be negative, because the only thing that's positive in the 2nd quadrant is sine, and we don't have sine. Okay? Answer for number 5 is 2. We did discuss that this is the amplitude, this is the frequency, and this is the vertical shift. Be careful, the amplitude is a positive 23. All this negative tells you is that your cosine curve would start down. Your amplitude should always be a positive number. So if they ask you what the amplitude is, you say it's 23, not negative 23. Okay? All right, so they want the range of temperatures. So think about, we're in summer, right? A hot summer day. Your range in temperatures, maybe the lowest temperature would be, at 3 o'clock in the morning, and it'll be 65 degrees, and then we go up to 88 degrees. So we deal with a minimum temperature and then a maximum temperature. This is asking the same exact thing, range in temperatures. Okay, so the minimum, here's the formula, vertical shift minus amplitude. If you don't know that, write that on that notes packet that I gave you, put it on the very back. And maximum is the vertical shift plus the amplitude. So vertical shift minus amplitude is 33, vertical shift plus amplitude, 79. There's your answer. Number 6, the answer is choice 2. You know what I'm going to tell you is an equivalent form. Cheat. Put it in your calculator. 2 stores x. Throw that in there. And then this one, when you throw that in there, will match up because it says which expression is an equivalent form. Number 7, the answer is choice 3. I am going to distribute that and I will get 3ai squared, and then I'm going to distribute that and I'm going to get negative 18 I cubed. Now, you may have I squared and I cubed memorized. If you don't, remember there's the I button. You have to hit second and then the decimal button. So I squared is negative 1. I cubed is negative I. And then we're just going to simplify that. So this is going to be negative 3a, and this is going to be plus 18i. Answer to number 8 is choice 1. What I did was I just went into y equals log x, and I just got this picture, okay, and it goes through the point 1, 0. This is what we call the behavior of a log equation. So it generally shoots up to the right, not always, but for basic log, it does. And then do you see here, we have an asymptote, meaning this curve gets closer and closer and closer and closer to this y-axis, but it's not going to cross over it. So when we look over here, to me, it looks as if the asymptote would be right there. And do you see that that's at negative a? What that means is, in terms of the equation, okay, our asymptote will be we'll be looking at what's inside the parentheses, okay? And technically, what we're really doing is, I'm just going to throw this one right over here. We take that x plus a and we set it equal to 0. And if we do that, we get x equals negative a. And that matches the equation of this asymptote. That is x equals negative a. Okay, but now we have to look over here, and if I take that x plus a equals 0, do you see that also is x equals negative a? So it could be choice 1, it could be choice 3. Whereas if you take either choice 2 or choice 4 and you set them equal to 0, you end up with x equals, I can't fit it, but you end up with x equals positive a, which is not what that what this asymptote is. Okay, so that's how I know that the answer is not going to be choice 2 and it's not going to be choice 4. All right, so then we're basically down to this plus c or that minus c. And if you notice, this graph is up here and it's not down here. So this means we're going up a distance of c. So what I'm basically doing is I'm taking this and I'm shifting it to the left, opposite direction of that sign, to the left a certain number of units, and then I'm shifting it up C. And then my picture looks like that, which is what I have here. This one would be shifting it to the left, but then going down, and then my picture would look like that, which is not what I have here. Number 10, the answer is choice 2. And you know what I'm going to tell you to do. Cheat. Okay. Number 11, the answer is choice 3. You know what I'm going to tell you to do. This one, you know, we don't cheat in the same way we do on number 10, but you know that you can hit your second matrix and throw all of that in. Okay, the one thing that you just want to please make sure of is that all your x's are lined up, which they are, all your y's are lined up, which they are, and your z's, then the equal sign, then the whole numbers. And if that's the case, you can throw this into the calculator. Number 12, the answer is choice 1. Okay, why? Well, it wants to know the roots. So in other words, you want to find out what x equals. So what I would start by doing is getting everything to one side. And I like to get it to the x squared side because I know that that's a parabola. And usually I'm going to factor. Notice I said usually. Look at your answer choices though. You've got i's and you got radicals that don't break down. So that means this is not going to factor, and we're just going to go straight into the quadratic formula. So I put my values for a, b, and c right above there. You have the quadratic formula. It's in your formula sheet there. So I'm going to do x equals negative b plus or minus. Then it's b squared. Please make sure you put that in parentheses because of that negative. Okay, b squared minus 4 times a times c. And that whole thing is over 2 times 1. Okay, so the next line down, I'm just going to say do 4 plus or minus. We'll deal with that in a second, and over 2. I would like you to then just take your calculator and put this in exactly as you see it. You must put the parentheses there, otherwise it's going to give you the wrong answer. And throw this in. Do not put the radical in your calculator, just all of these numbers. Okay. When you do that, you end up with negative 36. And if you remember, we can't have a negative underneath the radical. It's really an I. So what this really gives us is 4 plus or minus. Now the square root of 36 I know is 6, but I'm going to put an I next to it because of the negative. And then it says that it's got to be in, well, it doesn't say, but if you notice, our answer choices with i's are in a plus bi form, which essentially means I'm going to take that and I'm going to simplify that. That's 2. Then I'm going to put the plus or minus, and then I'm going to simplify those guys, and that's going to be 3i. All right, number 13, the answer is choice 1. Cheat. That's what I say. Cheat. Okay, now that being the case, I know you and I had done some long division and it wasn't your favorite thing, so I am going to show you how to do it. Pay attention to it, okay? I know you can mathematically cheat, but I think this is good practice because it won't always be a multiple choice question. All right, so notice there's no x squared. Oops. All right, so I am going to write 2x cubed plus 0x squared plus 2x minus 7. All right, look at this, look at this. What do I have to multiply by? X squared. Now remember, whatever I put up here always has to get multiplied by both of those terms. Okay, so that's going to give us 2x cubed plus 4x squared. I like to do the parentheses and the minus, but it's up to you. 2 minus 2, this is going to cancel out. Then I'm doing 0 minus 4. So this is gone, and this will be negative 4x squared, and bring the next term down. Okay, we repeat. What do I multiply this by to get to that? And that would be a negative 2x. Now remember again, whenever you put anything here, you got to multiply it through to both of those terms. Okay, so that's going to be a negative 4x squared and a negative 8x. And I always put the bottom in parentheses and I subtract. Negative 4 minus negative 4, that's going to cancel out. And then we've got 2 minus negative 8, and that's going to be 10x minus 7. And then the last time, what do you have to multiply 2x by to get to 10x? That would just be a 5. And remember that 5, you have to multiply it by both of these terms. Okay, so that's going to give me 10x plus 20. And let's subtract. That will disappear, and that's negative 27. And so we can write that answer as negative 27 over, and it's always whatever we're dividing by, which in this case is 2x plus 4. The answer to number 14 is choice 3. It says exponential regression. You take your calculator and you're going to go into Stat, Edit, and you'll see your lists. What you're going to do is all of these numbers go into your list 1. These are your X values, and these are your Y values. Those go into your list 2. Okay, once you have all that in there, then you hit Stat again and arrow over to Calc. And then you're going to go all the way down till you see EXP reg, which is 0, because we're doing exponential regression. Okay, and then you just keep hitting enter. And when you do that, you get that equation. So they list it as this is your A and this is your B. So I just plug them in. Okay. All right. Now this is where the somewhat tricky part comes in. They want to know how many followers she had on June 2018. June 2018 when we started in January 2015. So I would ask myself, all right, how much time goes by from January of 2015 to June of 2018? And this is where the trick comes in, because I tend to make this mistake as well. So I'm like, oh, that's 3.5 years. Well, that's 3.5 years, which, by the way, they want to know, this is all in terms of months if you look at the chart. So 3.5 years, if you do the math, 3 years is 12 times 3, so that's 36 months. Plus another half of a year, which is another 6 months, which would be 42. So essentially, that number is supposed to go in here. However, this says June 1st of 2018. So when we do all of this beautiful work that we did up here, that is taking into account of a full month of June. And that's not what this is saying. So we counted one too many months. So we should not be putting in 42 months. We should be subtracting that full month of June away. So 41 is what's going into your X. And then you just take this and throw it in your calculator, and you'll get that answer of choice 3. The answer to number 15 is choice 3. This is a little bit tricky. It's actually not hard mathematically, but it is tricky. So they want to know, based on this function that they gave you, it says this function can be best approximated by. So in other words, which ones are equivalent, or which one is equivalent to this? I want you to notice that this says I equals I sub 0. Same thing here, same thing here, same thing here, and same thing here. Okay, so essentially, I'm going to take this equation that they gave me. I'm going to ignore that I equals I sub 0, and I am going to just look at that piece right there. That's going to help me figure out which answer choice it is. I'm going to just rewrite that. So that's e to the 3rd power times negative t over 0.6. All right, there's another way to write that, so I want to show you. E to the 3rd. Do you agree that there's technically a 1 here? So this is 1 over 0.6 with a negative in front of it. Okay, 1 over 0.6 with a negative. So I'm just going to write it slightly different. Watch this. Negative 1 over 0.6. Okay, just like that. T. So there's a reason why I did that, so just hold on a second. This really here is the same as what I have right here. Would you agree with that? Okay, process that. So now all you're going to do is you are going to take, let me put this in blue so you can see it. You're just going to take this piece right here and throw that into your calculator. Type it exactly as you see it and throw it into your calculator. And when you do that, you end up with 0.0067. And that is why the answer is choice 3. The answer to number 16 is choice 4. This was a nasty question, I'm not going to lie. Like you saw from the other video, normal distribution, we have a mean we have a standard deviation, and then they're asking for a percent. We know that's got to be normal CDF. Here's the part that's a little tricky. Okay, so they want to know what percent of students would have a height less than 60 inches or greater than 75 inches. I'm going to tell you, I have never seen a question like this on the Regents before. And I'll explain. It's for a 2-point multiple choice question, I think it's a lot of work. But anyway, okay. I'm going to divvy this up into 2 separate sections. I'm going to address the less than 60 inches. So less than 60 inches, normal CDF. That means this guy would be the upper, and then we'd have numbers lower than 60, right? So you know I love 999. I'm just going to make it negative because I want it to be like a super, super exaggerated number lower than 60. So negative 999 would be your lower. Upper is 60. Then you put your mean in. Then you put your standard deviation in and just keep hitting enter. And this is what you end up with. So what we just got was the percent of heights less than 60 inches. But they also want the percent of heights greater than 75 inches. So now here we go with that. My lowest is going to be 75 because I'm going to have numbers that are greater than that. I exaggerate a really high number, 999, mean, standard deviation, keep hitting enter, and this is what you get. So they want to know what percent of the students would have heights that are either less than 60 or greater than 75, or means you take these 2 values right here and you add them. So all you're going to do is take that 0.00860 and you're going to add the 0.02120, and that will give you the answer to choice, which would be choice 4. Number 17, the answer is choice 2. They're asking for the standard deviation. Here's the thing, usually when we've been doing this, we've had numbers here in that corner. Okay, and one of them usually is the standard deviation. Well, they didn't give it to us. But we do have this formula that I hope that you learned, and it is the margin of error is equal to 2 standard deviations. And then the formula for that would be 2 radical P Q over N. All right, so this is the formula for the margin of error. Now, so we've got 2 and we have a radical, and then we have a P, we have a Q, and we have to put in an N. I don't know whether you learned this or not, but if you read through this, it says they randomly surveyed 100 members. Let me underline that, 100 members. And down here, they also talk about the 100 seniors. So getting back to this, 100 members of the senior class, and 43% of them said they would be interested in being in a senior musical. Notice that that 43 would be right in here. Okay, that's at the center of this normal curve, this bell curve. So that 0.43, or that I should say 43%, which we can change to a decimal, is your P. And then your Q, you know how every percent is out of 100? So if this is 43%, what's the leftover percentage out of 100? And that would be 57, right? Because 57% plus 43% is 100%. So 57% would be written as this, and that's how you find your P and your Q. I'm going to go right here, 2 radical 0.43 times 0.57. All right, the N. N always has to be a population of people for what we're going to do anyway, and that would then be 100. Now, you put this into your calculator, exactly as you see it, and I get 0.09 Please be very careful. What you just found is the margin of error, which is not what they asked for. They asked for the standard deviation. But remember what I said, and I wrote up here. A margin of error is 2 standard deviations. So what I have right here is 2 standard deviations. This wants 1 standard deviation. So all I do is divide that by 2, and I get 0.0495. That is your answer. Okay. Number 18, the answer is choice 1. I really think the best way to go over this one is in person. So if you want to star this one, unless you understand it, if you want to star it, just go ahead and start and we'll go over it together. Number 19, the answer is choice 1. You can totally cheat on this one. So in other words, put in -6, store as x. Then what you would do is you would type in this left side of the equation, get an answer, and then type in the right side and see if you get the same thing. If you do, then you know that that's a solution. Now, because -6 works on the left and the right, you would want to go through all the other answer choices, and I see here this also has 5. So if I were you, I would do 5 store as x, type in the left side, type in the right side, and see if you get the same thing. Okay? If you did, then our answer would be choice 3. But if you do 5 store as x, the left side doesn't equal the right side. So that's why your answer is choice 1. Okay, for number 20, the answer is choice 4. And look at this, is equivalent to, I would cheat. So I would maybe do 2 store as x and then 3 store as y. Remember your y button? You hit the alpha button and then y is above the 1. Okay, see how there's a green y above the 1? So you would alpha, then the number 1, and that's how you get the y on your calculator. So you would type this in, get a number, and then type this in and see if you get the same number. You will. Type this in, see if you get the same number. You will. Type this in, see if you get the same number. You will. 21, the answer is choice 3. Okay, so this time they gave you the inverse function and they want you to find the original function. It's going to be the same thing, or the same format, the same plan, the same steps if they gave you this and they asked for that. Okay, so we're just going backwards. Don't worry about it. Remember, this is just a fancy way of saying y, but just for the inverse. Okay, but I'm going to replace that with the letter y. I'm just going to rewrite it right here. So y equals 2/3 x plus 1/6. If we're dealing with inverses, hopefully you remember inverse means just to switch the x and the y. So instead of writing y equals, I'm going to write x equals. And instead of writing 2/3 x, I'm going to write 2/3 y. And that's how we find an inverse. So believe it or not, this is the original function f of x. But I don't really see any of that here, okay, because that's a y and that's an x. So what we usually like to do is once we switch the x and the y, we like to get the y by itself. I'm going to just start by subtracting 1/6 over. That'll cancel that out. So I have x minus 1/6 equals 2/3 y. Now I need to get rid of that 2/3. I know some people like to just divide by 2/3. It doesn't always really work out too well. So I like to do the more mathematical, surefire way every single time, which is just to flip 2/3 and make that 3/2. And what happens when you do that is you're going to get 6/6, which is just 1, which is good. We want to get 1. We want to get that y by itself. So what I do to one side, I'm going to do to the other. And now I'm just going to distribute that. All right, so when I distribute that on the left side, I'm going to get 3/2 x, and then I'm going to end up with minus. I can do 3/2 times 1/6 in the calculator. That's 1/4 equals y, which is the same thing as f of x, obviously. And there's your answer. 22, the answer is 4. Okay, we can mathematically cheat on this one. It wants to know how many equations below are identities. So this is 1 equation, 2 equations, or 3 equations, or none. So 2 stores x, 3 stores y. All you're going to do is you're going to type in this left side, get a number, and then type in this right side. If it's an identity, you should get the same identical thing, identity, identical, here as you do here, which doesn't happen for this one. So that's out. Do the same thing here. Type in the left side, type in the right side. If you get the same identical thing, then this is an identity, but you don't. Lastly, type in this side, type in this side. Do we get the same identical thing? No, we don't. The number that we get here will be different than the number we get here. So that's why the answer is 0. Okay, the answer to number 23 is choice 2. So I drew a picture over here, and you can see that I plotted 0, 6, and I drew the line y equals 4. That's the directrix. So if I have a focus here and I have a directrix here, that means the parabola has to be, its vertex has to be in the middle of these two things. So do you see there's a distance of 2? So I'd go a distance of 1 down, or from here, 1 up. There's my vertex, and my parabola is going to go like this because this is like a force field. So the parabola never crosses over there. So I'm going to just draw that now. So my parabola will look like that. This point right here is your vertex, and your vertex is 0, 5. Okay, the last thing that you have to remember is the P, and the P is the distance from the focus to the vertex, or from the vertex to the directrix. And that, regardless of which one you're looking at, that's still a distance of 1. Down here is the general form for a parabola. We know that our P is 1, so this whole thing is going to be just 1/4. And we know that our vertex is 0, 5. So I'm putting a 0 in here, and the 5 goes here. Okay, x, and then this ends up being our y value. So let me rewrite that. So that's going to be y equals, remember P is 1, so this is just 1/4. Now, this is technically x minus 0. You don't have to write the x minus 0 because what's x minus 0 is x. Okay, so let me rewrite that. Y equals 1/4 x squared plus 5. Okay, that's the answer, but that doesn't match up with anything that we have over here. Notice we have an x squared. So I have an x squared here, but I don't have an x squared here in choice 1, and I don't have an x squared there in choice 3 either. So those guys disappear. So at this point, it's either got to be choice 2, which obviously we know the answer is, and this one. But, you know, looking at it, besides me telling you it, you might not know. So I'm going to try to get, if you look, these both say x squared equals. So I'm going to try to get the x squared by itself. So I'm going to start by subtracting 5, and that will give me y minus 5 equals 1/4 x squared. Now, remember what I did on one of the last questions. If I want to get rid of that 1/4, the best way to go about that is flipping it, and that will make this disappear. And then I would do the same thing here, multiplying this by 4/1. Now, isn't 4/1 really just 4? Okay, so I end up with 4y minus 5 equals x squared, and there's your answer. Number 24, the answer is choice 2. And if you got it, move along. If you didn't, here we go. This is the formula. You get this on the Regents. Okay, your a sub 1 is your first term, and that would be represented by that $500 that they're depositing. So we're going to just do 500 minus 500. Now just be a little careful here. The account pays 4%. It's interest, right? So we're supposed to be making money. So technically, that's 1 plus 0.04. If you don't want to write it like that, I also like to just write it as 1.04. And it says on the child's 21st birthday, so that's the time. So I'm going to put 21 there. And then here, I do 1 minus r, which is the 1.04. And then you just put the whole thing in the calculator. And you'll, actually, let me take that back. We don't even have to calculate it. Here it is, right here. So this matches up with what we have right there. So this is one of many types of answers, I guess, that you could write. I do like you using the word randomly. So when they're trying to get a sample is just a sample. It's not every single person that goes to this local college. It's a sample of people. So don't say every person. Okay, so we randomly pick names from a list and ask their method of payment, but it is a random assignment or a random choosing, so to speak. Okay, the answer to number 26, right there in the top right-hand corner, is x equals 6, but we will reject x equals -1 because that's an extraneous root. All right, so I'm going to square both sides because that's how I get rid of a radical, and I'll get 3x plus 7. Please be careful on that right-hand side. When we have x minus 1, that quantity squared, that means we write it twice. And then I'm going to double distribute. So I end up with 3x plus 7 equals x squared minus x plus 1. Okay, so when I look at this, I see that I have an x squared here and I have an x squared here. So I like to get my x squareds together, and I like to bring the smaller one over to the bigger one. So I'm going to take all of this stuff and scoot it over here. But I do notice that these are like terms. So before I even do that, let me just rewrite 3x squared plus 7 equals x squared minus 2x plus 1. So I'm going to subtract over my x squared, subtract over my 1, and I'm going to add that 2x. Now there isn't a 2x on the left-hand side. Just because I really don't have anywhere else to put it, I'm going to throw it right there, but I'll fix that in just a second. So boom, boom, boom. So I'm going to end up with 2x squared plus 2x plus 6 equals 0. Okay, so my brain is fried. I made a mistake, didn't I? This is not 3x squared like I have right here. I don't know what in the world I just did. So this is all wrong. My apologies. Okay, so I rewrote it over here. Let's try again. So as I was saying, I want to get everything to the x squared side. So I'm actually going to move this stuff over here. Okay, because my goal is to factor. So I'm going to subtract 3x. I knew that kind of seemed a little weird, right? And minus 7. Okay, gone. So I have x squared minus 5x minus 6 equals 0. There we go. That seems a lot better. All right, so I'm going to figure out what adds to -5 and multiplies to 6. Okay, so let me just get my black up here again. Here we go. All right, so I'm going to use 6 and 1, and I need to get a -5 when I add, so that would be a negative and a positive. Okay, so let's just double check that I did this right. When I add 1 with -6, I do get negative 5. And when I multiply 1 with negative 6, I do get negative 6. Just to show you off to the side what a lot of kids do, 6 is a tricky number. I know that seems kind of like a weird thing to say, but watch. A lot of kids will do this. And they're like, well, Miss Carter, why does that not work? Well, this does. Negative 2 and negative 3 does add to negative 5. So that does work. And so I understand their thought process, but watch this. If I multiply negative 2 times negative 3, I do not get negative 6. I get positive 6. That's why this is tricky. Okay, so that doesn't work. All right, so back over here, I end up with x equals negative 1 and x equals 6. Okay, you must check your answers. And you can do this by cheating. So what I mean by that is do negative 1 store as x. Then type in this original radical 3x plus 7. Get an answer. Then type in this. Get an answer. And they should match. If they don't, you have to reject that answer. It's an extraneous root. And that's why that one disappeared. Okay, whereas if you do 6 store as x, type this radical 3x plus 7 in, and then the x minus 1 in, the left side and the right side will equal each other. So that's why this is an answer. There's your answer for number 27. I would just put this in the calculator. You're going to have to adjust your window because this is a high number of 37. So meaning when you hit that window button right next to your y equals, go to your y max and make it something a little bit bigger than this, like 50, 60, and then you'll see a picture that looks like this, okay? And it just asks whether the population is increasing or decreasing. We'll look at what's happening. As time is getting bigger, right? Your numbers are getting larger and larger. This is going higher and higher. So that's what this is basically saying. Okay, the answer for 28 is a equals negative 2. So if x minus 3 is a factor, remember x equals 3 is a 0. So what I can do is I can take this function and I know that it will equal 0 if I plug in 3 here and then 3 there, 3 here. Everywhere I see an x, if I plug in 3, it should equal 0 if it has a factor of x minus 3. So from here, we're just going to do the math, okay? So I'm going to do 0 equals, this is 27, plus 3 squared is 9a, minus 15 plus 6. So 0 equals, that's going to end up giving me 18 plus 9a. So I'm going to subtract that 18 over so that I can solve for a. So get negative 18 equals 9a. And then I'm just going to divide by 9. And there's your negative 2. For number 29, they want a recursive formula. So a recursive formula is a two-parter. We're going to have an a sub 1, and then we're going to have a sub n equals a sub n minus 1, and then we're going to have something else after that. So let's take a look at our sequence right here. This is our first term, so that's what we're going to be plugging in right there. Okay, so we're going to put in the 189. The next thing I'd like to look at is try to figure out what kind of a sequence is this. So in other words, am I subtracting a number from 189 and getting 63? And then am I then taking that number and subtracting it from 63 and getting 21? So am I subtracting by the same number every single time? And the answer is no. So this is not arithmetic. This has to be geometric. So in other words, I'd be multiplying 189 by something to get 63. Then multiplying 63 by that same something to get 21. Then multiplying 21 by that same something to get 7. Okay, so you got to figure out what that number is. Here, a friend of mine taught me this, and I like this way the best. If you want to know what that number is, they would call it R. You take the second term and divide it by the first term. And that will always tell you what you're multiplying by. And then throw that in the calculator. That's going to be 1/3. So if you try it, do 189 times 1/3. You'll get 63. Then do 63 times 1/3. You'll get 21. Do 21 times 1/3. You will get 7. Okay, so lastly then, because this is a geometric series, meaning we're multiplying, we have an R, then when we write this second equation, we multiply and then stick our R there. And there's our answer. Number 30, the answer is x equals 4.112. Now they say that you have to do this algebraically, so no cheating here. I am going to divide by 2. So I have e to the 0.49x equals 7.5. Now I'm trying to find x, and if you remember, we discussed this. If you're trying to find x and it's an exponent, you must bring this down in front. But we have to, and when we did it, I said you had to log both the bases, but we have an e, so we don't log when we have an e. The inverse of an e is an ln. So I'm going to ln there, and I'm going to ln here, because what I do to one side, I do to the other. What that does over here is that will cancel that out. Inverses of one another, right? They cancel each other out. It's kind of like here. I knew to divide because these two were being multiplied. So I did the opposite. I'm doing the same thing here. The opposite of an e is an ln, so that's gone. All right, so then over here, I just have 0.49x, and over here, I have the ln of 7.5. Now, if I want to get x by itself, pretty easy. Just divide by 0.49, 0.49, and then throw that in your calculator. And you will get x equals 4.11204, and then it wanted you to round it to the nearest thousandth. All right, last one, number 31. I am going to take that numerator, and I'd like to kind of look at this entire problem as two separate problems at first. So the numerator on one side, the denominator on the other. I'm going to factor. So here we go. On the left side there, I see they both have an x squared. So that would leave me with 2x plus 1. And on the right side here, I see there's a negative in front of that 18. So I want to take out a negative, and I'm going to take out a 9. So that's going to leave me with 2x plus 1. Take your GCFs, throw them together in one set of parentheses, and the 2x plus 1 in another. X squared minus 9, though, is the difference of two perfect squares. So one more, x minus 3, x plus 3, and then the 2x plus 1. There's my numerator. So I just factored that. Now I'm going to come over here to the right, and I'm going to do the denominator, and I see that they have a GCF of x. So that would leave me with 3 minus x. Very anticlimactic. That was so quick. Okay, I can't do anything more with this. So now I'm going to take this, which is the numerator, and this, which is the denominator, and bring them back to a fraction, which is originally how it was written, right? Okay, so here's my numerator in factored form, and here's my denominator in factored form. What we like to do from here is to see if there's any common terms in the top and the bottom and cancel them. So a lot of kids will just go whoosh, whoosh, cancel, done. You have to be very careful because these are not identical. That's a positive x. That's a negative x. Those are opposites of each other. Same thing here. This is a negative 3. That's a positive 3. These are opposites of each other. So when you have subtraction, and these guys are reversed or opposites of each other, you can still cancel them out. You can cancel them out, however, you should have learned that you need to multiply by a -1. I always like to put that -1 in the numerator. It's just me. You don't have to. You could put it down here in the denominator and just put a -1 right here. It's totally okay. So then my final answer is -1 times x plus 3 times 2x plus 1 over x. And that's your answer. Now, some kids won't write the 1. They'll just write a negative here and then the parentheses. That's also okay.